Hey guys, this is video number 5. This is actually the last video in chapter 5. So this is chapter 5, section 4. And this is all about, well, mostly about right triangle trig. And we've defined all of those right triangle trig functions elsewhere earlier in this chapter. So I'm not going to do that here. I'm just going to talk about the different ways to actually plug these into a calculator if you need to do so. And then there are a couple of other little pieces of info that you might need in order to do that. So here's example number 1 for your notes. It says, if in a right triangle, theta equals 14 degrees. Remember, theta is always an angle. And the side adjacent to theta has a length of 5. How long is the opposite side? Personally, for me, these are impossible to do without some kind of triangle and labeling and making myself a drawing. So I'm going to draw any right triangle, and then I'm going to put theta wherever I want it. I like this bottom corner all the time. So I know that that bottom corner is 14 degrees. And we're told that the side adjacent to it has a length of 5. And they want to know how long is the opposite side. So then you have to decide, based on the information you have, what trig function are you going to use? Well, I have the opposite and adjacent side, so I know I'm going to use tangent. And we always have tangent of the angle is equal to opposite over adjacent. So that's how you would set that up. Remember, you have the trig function, the angle, and then side over the side, always as a ratio, right? So no matter what trig function you use, you're setting those up that way. And then you're going to essentially cross multiply and divide to solve this ratio. So if I put this over 1, I then multiply the 5 by tangent of 14 equals 1x. And I would just plug this straight into a calculator, 5 times tangent of 14. And in varsity, this says round to the nearest thousandth. So round to the nearest EST. Oh my gosh, that was terrible spelling. Nearest thousandth. So just real quick to review decimal places, we have your whole number, the decimal place. This is the tenths. This one is the hundredths. Then this guy is the third one is your thousandths. NDTHS. And then this guy is your 10,000ths. Right? So you're always going to round based on the spot after it. So if we're looking at the thousandths, we're going to go to 4 decimal places and then round based on this digit right here. So I'm going to go to Desmos.com. This is a calculator. I don't know if I've shown it to you already in this class. So I'm going to go out to the internet. I have a link for it. It's Desmos, Desmos, but you can go to just Desmos.com. And when you get there, the website will look like this. And if you go to Math Tools right here and hit the drop down arrow, the second option down says Scientific Calculator. And I love this calculator because in my room, generally, decimals are not necessary and fractions are very, very, very useful. And this calculator does them very nicely. Here, we're actually using decimals, so that's kind of funny. But anyway, we said we wanted 5 times tangent of 14. So we're going to go 5, and then tangent, sine, cosine, tangent. Those are all right here. So tangent, oh, geez, I don't need that. We just plug 14 in, and then right up here, you get 1.2466. Now remember, we're using that fourth decimal place to round up. So we're going to have 1.247 when we answer this question. 1.247. So this is x equals 1.247. And that's what you would plug into varsity. Okay? So there's one example. I'm going to do another one where your fraction over here is flip-flopped, where the number's on the top and the x is on the bottom. So let's do another example. Example number 2. It says, if in a right triangle, theta is 5 degrees and the side opposite, theta, has a length of 4, how long is the adjacent side? Okay, so again, draw yourself a picture. I'm going to put my theta or my angle down in this corner, so I know that's 5. They're telling us the side opposite theta has a length of 4. Opposite is over here. How long is the adjacent side? That would be this side. Again, we have opposite and adjacent, so we have tangent, angles 5, opposite over adjacent. So I'm going to stick tangent over 1 and cross multiply. So I have x times tangent of 5 is equal to 4 times 1, right? But 4 times 1 is 1. And then I want to get the x by itself. So I'm going to divide both sides here by tangent of 5. These cancel each other out. And I get x equals 4 divided by tangent of 5. So I'm going to go back to my calculator. I'll backspace, I'll clear all. X equals 4 divided by, I don't have my keyboard attached, that's why I'm getting all of these. Divided by tangent, it's probably going to pop that up again, tangent of 5, and there's my answer, 45.7202. 45.7202. 45.7202. And again, the directions were to round to the third decimal place. So because my fourth decimal place is 5, well, smaller than 5, right? That's smaller than 5. I would just leave that third decimal place alone. And I would put 45.720 into varsity. All right. The next one is a little bit different. This one, you're given 2 side lengths, you don't know the angle. So let's take a look at this guy. Example number 3 says a 75-foot flagpole casts a 48-foot shadow. What is the angle of elevation to the sun? All right, so first you need to know what or where an angle of elevation is. So usually you're talking about some object. So here's our object. Could be a tree, could be a tower. In this case, it's a flagpole. And then usually you're talking about a shadow or the ground or something like that. And then the angle of elevation would be this angle that is created here. So here's the angle of elevation. And if you're asked for an angle of depression, that would be the angle, kind of pretend, if you will, that these two things actually came to a point. So I made a better line, and those are like that. Let me actually make a better line. We'll do that. So here's your angle of elevation. And then this guy in here is the angle of depression. And depression, depending on what you recall from geometry, when you have a Z shape created like that, these angles are actually equal to each other, right? Those would be alternate interior angles. So your angle of depression and your angle of elevation are the same value, but it helps you to label your object correctly or your triangle correctly. So in this case, there's our flagpole. Here's our shadow. I'm going to close my triangle, and here is where my angle of elevation is. So that's my theta, 75-foot flagpole, 48 feet. So once again, we have a tangent function. So I have tangent of theta is opposite 75 over adjacent 48. All right, well, important note here. You may or may not remember this from when you had algebra. Excuse me. In, I'm sorry, not algebra, but trig in geometry. When you do not know the value of the angle, do not know the value of the angle, you use, excuse me, I have a tickle in my throat. You use the inverse trig functions on your calculator. Let me just show you where you find those over in the Desmos calculator. So they don't show up right here. You have to actually hit the function button. Get rid of the keyboard. Oh, excuse me. And then they're the ones here with these -1 signs above them. If you have the little red calculator or graphing calculator, they are directly above the sine, cosine, and tangent buttons. You just have to hit the second key to get to them. All right, so what we're going to do here is we are going to use the inverse tangent button and just put this number in. 75 divided by 48. So we'll go do that over there. Inverse tangent, 75 divided by 48. And that's going to actually equal theta. So we're going to get theta equals 75, go back to the main. 75 divide, go back one. This really is a problem without my keyboard attached to this thing. Divided by 48. Oh my gosh. And you get 57.38. 57.38 degrees. And I believe this one said to round to the nearest tenth. So we would make this 57.4 degrees. All right, so that's the right triangle trig part. There's a couple of other problems that you need to know, a few things about cofunction identities, and then I have to make a statement about numbers 1 and 2. So real quick, cofunction identities. So these are just statements that we're going to make that are laws in trigonometry. And here's what I want you to remember. Just recall that pi over 2 is equal to 90 degrees. Okay, so the sine of pi over 2 minus u equals the cosine of u. And the cosine of pi over 2 minus u equals the sine of u. The tangent of pi over 2 minus u equals the cotangent of u. And the cotangent of pi over 2 minus u is equal to the tangent of u. And lastly, the secant of pi over 2 minus u is equal to the cosecant of u. And the cosecant of pi over 2 minus u is equal to the secant of u. And so here's how you would use these. In varsity, you're going to have a problem that says the tangent of 20 degrees is equal to the cotangent, and then they give you a blank. And the directions say something like, using cofunction identities, make this a true statement. So if you know that the tangent of something, we have the tangent of something is equal to the cotangent of pi over 2, or 90, minus whatever u is. So in this case, u is 20. So this would be cotangent of 70. And that's what would go right in that box right there. Okay, so that's how you can utilize these. Another one would be, they have something like this in there. Instead of an actual angle, it says the cosine of A. Well, the cosine of A, and then it says equals the sine of a box. So again, look for where cosine is something, and that's here. Cosine is equal to sine of 90 minus u. So this is equal to sine of 90 minus u, which in this case, the u is in A. And so that would go right up in here into this box. So this would be 90 minus A. Okay, so they're just asking you to think outside the box a little bit and not use numbers. All right, and then the last thing that you just need to know is that for problem 1 and 2 on 5.4, you're going to write only the trig ratios. I'll show you what I mean by that in a moment. You're not going to actually solve anything. I'll give you an example. So they give you a triangle. They give you two sides of that triangle. Let's say this is 2 and this is 6. And then they say fill in the sine, the cosine, the tangent, and then they work backwards, the cotangent. So just pay attention to the order of these. The secant, which is opposite cosine, and then the cosecant, which is opposite sine. So you're going to need to do Pythagorean theorem to find the length of this side. Let's do that real fast. 2 squared plus 6 squared equals whatever that is squared. So that's 4 plus 36, that's 40. We take the root of both of those. That's going to be a 2 rad 10 equals x. So this is 2 radical 10. So here's your theta, by the way. That's always in the bottom corner. So sine is going to be opposite over hypotenuse. So 2 over 2 rad 10. I think you can get away with not rationalizing these, but I think you need to simplify. So you may be able to get away with this. However, if that's marked wrong, make sure you rationalize and it's read 10 over 10. Okay. And then cosine would be, let's see, I'll change colors so it stands out. Cosine would be adjacent over hypotenuse would be 6 over 2 rad 10. You can simplify that to a 3. So that's going to be 3 over rad 10. If you have to rationalize, it would be 3 rad 10 over 10. And you should be able to do those in your head by then. So you're just literally putting these ratios in. Okay. You're not actually solving and finding the value of theta. Nowhere does it ask you to do that. Just the ratios. Okay. You'd find tangent. Tangent would be 1/3, right? 2/6, but then you reduce it. And then just flip them over. Cotangent would be 3 over 1, which would just be 3. Secant would be the reciprocal of cosine, which would be rad 10 over 3. And cosecant would be the reciprocal of sine, which when you rationalized would be the reciprocal of this guy, which would just be rad 10. Okay? That kind of thing. So that's what problem numbers 1 and 2 will look like. There's a couple where they give you like sine and ask you for all the cosecants, or they give you cosine and ask you for all the secants. And then there's a couple cofunction problems. And then I think with number 8, they actually get into the right triangle trig. Okay, so this is the last section for this homework. And then we will spend a couple days in class next week doing a chapter test review. Come and ask me if you have any questions with any of those. And then we'll take the end of the week to do a chapter test. All righty? Toodaloo.